Happy Tuesday, everyone. We're going to be talking about angles of elevation and depression. So our essential question today is, how do I use angles of elevation to find the distance between two objects? Your homework for tonight is going to be the worksheet on Google Classroom. I'll give you a moment to set up your notes because yes, we are taking notes today. Okay, here is a picture of an angle of elevation. I would like you to contemplate this picture for a moment and then write a definition for angle of elevation in your own words. So if you pause the video, we'll go ahead and go over it in a moment. We take what their horizontal line of sight would be, and the angle of elevation is only the amount of degrees they're looking up from there, up at the tree. So however you set it, make sure that you include that you are only measuring from their horizontal line of sight upward. Let's practice that with this picture here. So if you can go ahead and sketch this picture in your notes, we're going to go ahead and add an angle of elevation and an angle of depression. So you can start by adding in the horizontal lines of sight, both for the bird in the tree and for this cat down below. Okay, then if we draw a line of sight between the bird and the cat, we've got an angle of elevation here from the cat's perspective, but also for the bird looking down from their line of sight, an angle of depression as well. What do you think would be true of these two angles in particular, since their line of sight for both animals is horizontal? What do you think is true about these two angles? Okay, their lines of sight are parallel, so we've got a transversal here with parallel lines. These are alternate interior angles, meaning that they would be congruent to each other and equal in measure. Okay, let's try an example. So here's a story problem. You can draw this triangle in your notes. So Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? You probably don't need to write down the story problem itself, but what I would like you to notice is that Leah's height matters. So for our angle of elevation, we're only measuring from her horizontal line of sight upward. So for this side of our triangle, we're going to need to adjust. So instead of looking at all 190 feet, we're only going to look at 190 minus 5.5 feet, which is 184.5 feet, just for this vertical portion of our right triangle. So then we can set up a trigonometric ratio for this. If we're looking from where Leah is standing, we can go ahead and mark up our triangle for the opposite, adjacent, and hypotenuse. And then we can identify which of the two sides we are including. So right now we're looking at opposite and adjacent. So take a moment to look back in your notes and decide which ratio we will need to use for O and A. Hopefully you've had enough time to look at that. So that's O and A, that goes with TOA of our SOHCAHTOA. So that is going to be a tangent ratio. So we can set up the ratio tangent of 38 degrees equals 184.5 over x, and then cross multiply. So you might want to write that tangent of 38 degrees over 1. We'll cross multiply, and we get x times tangent of 38 degrees equals 184.5, and then there's one more step to isolate x. We divide both sides by tangent of 38 degrees, which is approximately equal to 236 feet. Usually we want to include a decimal, but here they're asking us to round to the nearest foot, so we'll keep the nearest whole value. So we can conclude that Leah is about 236 feet away from the castle. Or at least from that tower in the castle, because it looks like she's actually a little bit closer to it. Let's ignore that part, I guess. Okay, here we have another example for an angle of depression. In this case, we have a lifeguard watching a beach from a line of sight 6 feet above the ground. She sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? So we want to go ahead and create a right triangle out of this story problem. Part of it's already done for us, but we do need to fill in some more details. Okay, so here we've got our 6 feet put in. I've drawn in the right triangle from the lifeguard to the swimmer. And we can use this 8 degrees in one of two ways. Because these are alternate interior angles, these angles here and here will both be 8 degrees. Or you can use the idea that this here between the black line and the dashed pink line is a 90-degree angle to fill it in here. So let me show you what I mean by that. So this angle right here should be 8 degrees because these are alternate interior angles and these lines of sight should be parallel lines. Or we can use that information that this should make a right angle and subtract 8 degrees to find 82 degrees here. It doesn't really matter. And we are trying to find this distance between the tower and the swimmer, x. So I'm just going to go ahead and use this 8-degree angle. So looking from the swimmer's perspective, 6 feet is opposite, and x is the adjacent angle, so we have another tangent ratio. So we can set up the ratio tangent of 8 degrees equals 6 over x. Go ahead and cross multiply to solve that out. Once you solve it out, we get that the swimmer is about 42.7 feet away from the tower. Okay, last one. So I cut out some of the words, but I think you get the gist of what's being asked here. We've got a skier going down the slope of some ski slope. And we want to know what angle of depression they are skiing at. We want to know how steep this slope is. So we know that their slope is 208 yards tall, and that this whole ski run along here is 1,000 yards. We want to know what this angle is. Before we can find this angle, what do we need to find first? I'll give you a moment to think about it, and then come back to the video. Okay, so before we can find this missing angle in question, we have to find one of the interior angles first. It doesn't really matter which one, but since we know these alternate interior angles are going to be congruent, I'm going to go ahead and find this angle right here, angle B, or more specifically, angle ABC. And that will tell me what my missing angle here is. So if we label our sides, we're dealing with the opposite side and the hypotenuse. So we're dealing with the sine ratio. So we have that sine of angle B is equal to 208 over 1,000. If we take the inverse sine of both sides, the sine inverse and sine undoing, so we get B equals inverse sine of 208 over 1,000, which is about 12.01 degrees. I'm rounding this second decimal place up. So if this angle here is 12.01 degrees, then our angle in question is 12.01 degrees as well, because they're alternate interior angles of parallel lines. That concludes today's lesson on angles of elevation and depression.